analyzing data, and that is different ways to make your visuals show more in-depth analysis and not just showing like any kind of charts. And we'll continue that today and try to finish it up. Let me share my screen, and I'm going to continue using the same Power BI file that we were using last week. So this is how far we went last week. We did this top end analysis. Then we did conditional, I think this was conditional formatting using gradients, and then conditional formatting by rules. And afterwards, we did reference lines. We learned about all of the different kinds of reference lines available. And today I want to show us something called the play axis. That's where I want to start from today, using the play axis in Power BI. And what does a play axis mean? Play axis, just like the name implies, is it works like a slicer, but it allows you to play through sort of a historical, how something has happened over a period, kind of. So what that tells you is that, firstly, there has to be dates involved in what you're visualizing. So how do you use the play axis? To use the play axis, you would already have like a visualization, which could be any kind of visualization at all. But I'm going to use this map visual that we did last week. And then the play axis, you will not see it here on your visualizations pane. You have to import it. So first thing, make sure that you're logged into your Power BI. As you can see my name here, which means that I'm signed in, because you cannot import new visuals if you're not signed in. Then you come here to these 3 dots here, where you can get more visuals, because the play axis doesn't come here automatically. So when you go to get more visuals, if you're not signed in, it will first ask you to sign in. Then when you come here, instead of scrolling through all of them, we know that we're looking for the play axis. So just put it in the search bar, play axis. See the play axis here is a dynamic slicer. Select it and say add. So once you do that, you would see the play axis here. Normally, every time you get more visual, you just see the visual here. So now to use it, of course, just the same way you would do when you're creating a new visual, you click outside your visual that you already have, and then you click on the play axis. And as usual, just like every other visual, it asks you to drag a field. So what field do you want to play through? And like I said before, play axes are best used with time or date fields. So I'm going to first try with year. So I'm going to just drag year into the data field here. And immediately you see it here. You see year, and then you see your play button, stop, pause, previous, and things like that. And the moment you click play, what it does is it plays a visual of all the years that you have in your data set. And like at different points in time, for example, when I click play, I can stop. When I click play, I can pause at 2012. So this chart here is showing the situation as at 2012. And then I can play again. I get 2013, I pause. This is as at 2013. And if you look at it, you see how it changes based on all of the years. Now it's not looking so interesting because we have only 3 years. So I remove the year and I'll use month. So we have 3 months. So let me use month name. So we'll see how the thing changes from January to December, and you can just play it again. Then it goes January, February, March, April, May. So this play axis can be used with any kind of visual at all. And it just shows you how the thing is moving from one month to another. So instead of having a slicer, like for example, a month slicer where you have to select all of the months one after the other, you can just use this play axis. That way, instead of selecting January, February, March, once you just click play once, it shows how it moves from each of the months to like up to January to December. So those are the ways where you can use the play axis. Of course, you can also use quarter, or you can use the exact dates depending on what you're trying to achieve. So that's the play axis. Now, the other thing that I want to talk about in analyzing your data is grouping and binning. And I'll go back to this example that I used last week, where we had all of these states, all of these plenty states here. The states look like they are a lot, and you can almost not make sense out of it. And even though luckily for us anyway, in this data set, we had the states grouped into zones. But let's assume that we didn't have them grouped into zones, but you want to now group them by yourself. So instead of having Ebonyi, Delta, Nasarawa like separate, you want to group them into Northwest, Northeast, South, and whatnot. How do you go about it? If it is not already existent in your data set like we already have here, the way to do it is to come here to where you have state. Where you have state on your fields pane, you can actually go different ways, but this is just like the most straightforward way. And click on these more options. When you click on these more options, you see the option that says new group. So when you click this new group, it brings up this dialog box. What do you want to name your groups? So it gives the default name, which is state groups. I'll just change it to geo zones because I want to use it like something that we're familiar with. So what field do we want to group? Of course, it's states. So now these are all the values that we have in the groups. And then how do you start grouping them? You group by selecting. So you select, use your shifts, and then continue to select as much as. Of course, if you want to select like maybe separately, not maybe they are not on the same, you hold your control and then continue clicking all the states that you want to select. To make this easier for us, I'm going to just do random groupings. So I'm going to group these ones first and call them. So the moment you select some from here and they move to this place, they are removed from this place. So I'm going to call this north. Yeah, these are not the correct things, but this is just me trying to avoid spending time to be looking at the states one after the other. So now we have north, then I'll select another 5. I'll group this, call this south. Then I'll select another 5 or 6 or any number. I'll group. I'll call this east, and I'll select all the remaining group and call this west. So now you can see that here is empty. So that means the ungrouped values are now empty. So we've grouped all of the state values, and we now have all these zones: east, north, south, and west. And you can use the arrows to check which states are under, just in case you make any mistake. You can actually remove it, and like you can actually like ungroup it or stuff like that. Like you can say ungroup, and that one just comes out of it, and then you take it to like any other group that you want. So okay. So now these are all the groups that we now have. Let me ungroup this and take it back so I can have the list there. So now we have all our groups and we can then use it. Of course, you have to click OK. So when you click OK, instead of having states here, you can remove these states and then have geozones instead. So you have west, south, north, and east. So that's how grouping works. And you can use grouping really for any kind of stuff that you're trying to do. For example, you have maybe names of different staff and they're in different departments, and the data did not previously group them into the different departments that they are. Then you can use grouping to group them. Or you have maybe products that you're selling, and some of them are like different departments. Maybe some are raw materials, some are food, some are groceries, some are whatnot. So any kind of data, especially that is text, you can group them like this. Now, what is the difference between grouping and binning? The basic difference between grouping and binning is that grouping is used when you have likely texts and then there's a finite count. What that means is that, for example, assuming you had like 100 states, you can imagine how difficult it would be for you trying to group them. And then you are now selecting four. You spend forever trying to group them. So the count is not plenty, and then their text. You can use grouping for them. Binning, on the other hand, is used for numbers. So the things that, and when we do the example, you understand it. When you have a group of numbers, for example, maybe you have age of different people from 5 years to 100 years, and then you want to put them in different groups. Because those numbers are a lot, like I said, and you can't begin to select them one after the other to say 5, 6, 7, 8, and 9. With binning, there's an easier way to do it where you can also just still group them based on how the numbers are. And let me just show you an example of binning, and you see the difference in what I was saying. I'm going to use unit costs in our sales details to show us how to do binning. Yeah, unit costs here. As usual, you right click on these 3 dots and then you click new group. Can we see the difference between when we click new group for a numerical value and when we click new group for a text value? I'll just quickly show us again. See how this one shows. This one has like different sets of fields. But when we do for, let me use this products new group, you see that when you're grouping something that is like text, that they are not numerical values. Like this one, even though there are a lot of product names, because it's not a numerical value, you cannot bin it. You can only group it. And this group type is not even highlighted. You don't have the option of changing it or not. So you have to use a list and you have to select them one after the other to group them. So anything that is text can only be grouped. It can't be binned. But if you have numerical values, they can both be grouped and be binned. And I'll show you for this numerical value that we were doing just now, which is unit costs, new group. So can you see, it gives us the option of course, the name of the group. It has called it unit cost bins. I'll just leave that. Field we are using is unit cost. Now it's asking you group type. Do you want a list or a bin? If you say you want a list, it takes you back to that type, the type you have when it's a text. And the values are like gazillion, of course. If you want to select it one after the other, it's really your headache. But the easier way to work with numbers is to use bins. And what are bins? Bins, just like the name implies, just like grouping, it just means that you're putting, okay, all of you that are between 1 and 10, enter this bin. Between 10 and 20, enter this other bin. Between 20 to 25, enter this other bin. And the only rule that is just valid here is that when you're doing binning, all the bins have to be the same size. You cannot have bins that are different sizes. Like you can't say 10 to 20, 20 to 30, then 30 to 50. No, all the bins have to be the same size. So once you say 0 to 10, 10 to 20, 20 to 30, 30 to 50, like that. If you want your bins to be irregular sizes, you have to use DAX to do that. But if your bins are all the bin sizes are the same, you can use this binning. And there are different ways to create your bins. You can either specify the size of bins or the number of bins. When you're specifying the size of bins, it means that you want to say, I want the size of the bin. Like if you want to be between 1 to 50, 50 to 100, you say you want the size of the bin to be 50, stuff like that. But if you want to specify by the number of bins, this is me saying, I don't know how many values there are in the, this is you saying, I don't know how many values there are in the data set or how big the sample size is. I just want you to divide the whole data set into 5 groups. So I'll come here and put, let me just say 10 and put 10 here as the bin count. Once you put the bin count, he automatically calculates the bin size because he already knows the minimum value and the maximum value. So he separates all of those things into a bin count and gives you what the bin size is. Like, of course, so you know that if you have more bins, the size will be smaller. So when I had 10, the bin size was 189. If I increase the bin count to 20, the size will be smaller. So that's just like basic mathematics. So I'll leave the bin count as 10. And then I will say, okay. So let me use it in a visual. Let me create a new this and call this binning. So I would drag the unit cost bins here. So we can see all the bins that we have. Now, when you do bins, the value that is shown on the bin is the lowest value for that group. What that means is that this first bin contains unit cost between 0 and 189. Then the second one contains unit cost between 189 and 379, like that. I'll use it in the visual so that we'll understand it. Let me plot it with profit. And then let me take this to a column chart. So normally this column chart is supposed to show us, let me increase the distance so that we can see the size. The y-axis and size. So what this is supposed to mean is, like when we had the table, let me show the table again so that will show us something. Let me change it to the table. That's not what I meant. I want to show us something with the table. So when we had this table, like it was obvious that, okay, well, this first bin is 341. The second bin is 14. The third bin, the profits inside the third bin, 189. Fourth bin, 271. But by the time we take it to this chart, the whole thing is scattered. Like it just says 0, 500, 1000. Instead of each of the bars having their individual scores, it's just scattered like that. And there's a solution to that. You have to come here to format your visual, the x-axis, instead of it being continuous, change it, because what we have is different categories. It had given us an x-axis that is continuous. So that way you have to like hover over it to see what is the value for each of the bins, which is not productive. But because it has used a continuous scale. So when you come here and change the scale to categorical, now each of the columns have their own value. So the columns, the products with unit cost between 0 and 189 made a profit of 341 million. The ones between 189 and 372. So just picture this like a histogram. And so now we have successfully grouped all of our sales into bins based on their unit cost. And what this can tell us at a glance is that we're making more profits from the products with lower unit costs. Of course, it goes without saying because the cost is low, so we're able to make more profits by maybe selling it at a higher price. So that is it on grouping and binning. Like I said before, please don't forget, you can, for when you have numerical values, you can choose to either group or bin them. But the best practice, especially when the values are a lot, is to use binning. However, when you have text values, you cannot bin text values. You can only group them. Also, final rule to remember is that when you're binning, the bin sizes have to be uniform. If you want to create bins with different sizes, you cannot use this binning process. You have to use DAX and use the switch function or the case function or any of those. So that is that on grouping and binning. The next thing that we would do in analyzing data is, does anybody have a question on grouping and binning? No questions. Okay. So when you're analyzing your data, there's
I'm sorry.
yeah.
Yeah, I think I got something wrong. When you were explaining earlier, you said that we could use binning for numerical data and text, but grouping
No,
is
no,
only for
no.
text.
I said no. I said
But
grouping. You can use grouping and binning for numerical data. That's what I
okay,
said. You can, for numerical is the one that has freedom. Just know it like that. Numerical data has freedom. You can either group it or you can bin it. But when it comes to text data, you can only group it. And when we did that situation, you will understand why. Because if your data is text, so let me go back to where I was binning the unit costs. Imagine that you're trying to create a bin and you have maybe text. How is this guy going to determine the like even if you say, okay, I want 10 bins or how is he going to determine which people to put in the same group? Because binning works based on numbers, like a minimum to a maximum. So I have 0 to 100. The way binning works is it takes 0 to 10, then 10 to 20, then 20 to 30. But if it is not a number, if it's a text, say agbalumo, mango, orange, how is it going to know which people to put in the same group? Do you get? Sorry, to put in the same bin. But because binning works based on sizes, so it bins numbers of this, like smaller numbers, then the next level, like that. But when you have text, you can't bin them. The reason you have to group them, because you're the one that knows the ones that look alike. You're the one that knows that agbalumo, mango, and orange are fruits. Then eba, amala, and tuwo are actual food. So you know how they relate and how you want to group them. So that's why you have to select them individually to group them. But with numbers, you can just say, you can just decide, once you've decided the number of bins or the bin size, it will just take the smallest, the next smallest, medium, and the highest. Am I making sense?
yes.
Yeah, so just understanding that numbers have more flexibility. They can either, numeric values generally, they can either be grouped or be binned. And that applies to also date values and time values. Because again, it is easy for Power BI to know which dates are, like, it's easy for Power BI to arrange them in an ascending or a descending order. But it doesn't know how to arrange texts. Of course, even though you can arrange them like in alphabetical order, but alphabetical order many times may not always make sense depending on what you're trying to achieve. So that's why for texts, you have to group them. And what that means, like you have to use your hand to select who you want to be in what group. Does that make sense now?
Yes, yes, thank you.
Yep. So, okay, I wanted to talk about outliers. There are many times that your data will have outliers. And for example, in a company that sells whatever, in 1 week, somebody went somewhere, maybe to an event or to redeem camp and spoke about their products, and everybody rushed and came to their website to come and buy. What will happen is that month the sales will just shoot up, and then when you do your analysis, you see that it's just stand out. But if you're not even looking at your data properly, you might not notice those outliers. And so there are different kind of visuals that sort of helps you to identify outliers in your data. And one of those kind of visuals is the scatter plot. So sometimes even when maybe, especially if your data was like data of January to December, like the data points are not a lot, it might be very easy for you to identify outliers. But when your data points are like 100 or 200, you can't just be looking at the table and be looking for outliers. So in those kind of times, you use these charts to find outliers in your data. And I will bring up a scatter chart, a scatter plot, whatever you want to call it. And how do you visualize data, scatter charts? You use scatter charts to check the relationship between two numerical values. So you have to have two numerical values and then one value that will serve as like the legend or whatever. So the two numerical values I will use here, I will use unit cost again and profit. And I have a reason why I'm using it. I'm going to relate it to something that we did or that we said earlier. So unit cost, the first value, and profit is the second one. And so unit cost and profit against what? We've not added the distance. So what we're checking it by, so let me just say stayed. Now this, if you remember your normal straight line chart, of course, in secondary school, y is equal to mx plus c. So if you draw this straight line here, you can see like the relationship between profit and unit cost. Of course, higher unit cost shows higher profit. But can anybody already see an outlier in this data? Can anybody see an outlier?
Yes.
Okay, to make it more interesting, because all of the dots look like the same color and the same this thing, I can do something to make it look better. So let me move this state to legend. So each of the states can have different colors. So what color is what state is the outlier? What state is the outlier? I thought somebody saw the outlier.
Imo State.
It's not Imo.
Oh,
Yes,
sorry.
Imo.
Blue or something. Ebonyi. Ebonyi.
Ebonyi State. Now, make this more interesting. We can still add another field that makes the outlier even more obvious. So what we did here was profits against unit cost, Abby. So we can decide how we want the size of each of these balls to be. So I will drag profits again into the size field in this field pane. So Ebonyi States, not only do they have like, despite that they have like, yes, high unit costs, they still have very high profits. And so now that we have seen that Ebonyi State is an outlier, they have really high unit cost, but somehow they still manage to have high profits. Then we need to go and ask Ebonyi State people which jars they are using, that their cost is this high, but somehow they are still able to make this much profits. Of course, they are now the job of the analyst is now to go and maybe discuss with the businesses, find out what's happening in Ebonyi State. And sometimes these outliers could even be as a result of an error in the data. But by at least by the time you start asking the questions, you now find out that, oh, there's a mistake in the data. That's why it's looking as if it's an outlier and things like that. So these kind of charts help you to like easily find outliers in your data. Like imagine that this one, we even have maybe 26 states, so it's not a lot. But imagine that you had like 100 states or like 100 regions. You can start looking at them one after the other. But once you plot this kind of charts, you just see where the outlier is and you can bounce it off or ask the right questions to check why what is happening. And then next we'll go to something that looks quite like outliers, but then key influencers. So now that you've found that Ebonyi State has this outlier and whatnot, sometimes you now also want to check what is influencing. Maybe you now want to even check what is even influencing this profit. Like what is the biggest driver of profit? Like, because I always say in data analysis, anybody can come and give statistics and say, oh, 64% of our profit is blah, blah, blah. But the why is what is called the performance drivers, especially maybe in HR or in sales analysis. The performance drivers, what is driving the sales? What is making the sales to behave the way they are behaving? Now, to do those kind of analysis, you can use what is called another chart, the key influencers chart. Key influencers. So the key influencers chart is this guy here. You bring it out. And then, like I said before, what we want to analyze again is, should we use profits? We can actually use profits, can use total sales, but let's use profits. So we're analyzing profits. It's not showing anything yet because you've not added any field. What do you want profits to be explained by? And what this means is that when you say explain by, it means you want to check the impact of this thing on profits. So I can start with what happens is if you put a field that doesn't have any impact on profit in the explain by field, it will tell you that there's no relationship. For example, let me put order ID. It tells me no results found. Try adding some more fields. What it means is, let me try another one. There was one that I used earlier. Promotion. It runs the analysis and it tells you no influencers found. It means that this field I have added doesn't have any impact on profit. And that's because all these fields I'm adding, they're even text, they're not even numbers. Then finally, I'm going to just use order quantity. No influencers found still. Let's see unit costs. What did I use earlier? But let's explain order quantity by unit costs. So you just have to like keep finding where there's a relationship, and it just feels like in Python when you're trying to find the correlation between two values. That is exactly what we're doing here. We're checking, is there a relationship between this guy? Does this guy have an impact on this other guy? So what we have done here is we have tried to analyze order quantity by unit cost. So what we are saying is, does the cost of a product have an impact on how many of that people are buying? Does the cost have an impact on how many people buy? and already you can see the impact. So you have to like really read this to understand what is happening. It says when unit cost is between 4 and 375, the average order quantity decreases by this amount. And once unit cost is more than 375, the average order costs decreases by this amount. And you can also change it to increase. And it just flips it. So what causes the unit cost to order quantity to increase is only when your unit cost is 4.3 or less. The average order quantity increases by 359. So you can like see the, of course, there's also a chart showing you, and it has also automatically created a unit cost bin to show the different categories of unit cost and how the order quantity changes in each of those categories. And what this means is that for the items with very, very low unit costs, people tend to buy more, which is kind of understandable. The things that are cheap are the ones people buy the most. And that's why, if you remember clearly, when we did our binning, the profits like was really high for this smaller category of unit cost. And that's because we sell a whole lot more in that category. So of course you can also change it. Like I said, you can change it from increase to decrease. Then you can come here and see what is called top segments. So you see the different segments. This is the first segment. When is order quantity more likely to be low? You can also change it to high. Order quantity is more likely to be high in segment 1 and in segment 1. You have to select the segment to see more details. Segment 1 is again the segment where the unit cost is less than or equal to $4.3. So that's the segment where order quantity is very high. Average is 49 and it's 32.6 higher than the overall average. When is order quantity more likely to be low? Of course, there are two segments. First segment is the segments where unit cost is greater than 4.3 and less than 375. The second segment, unit cost is greater than 375. So at all of these times, the order quantity is low. So it just sort of gives you a lot of insights into what's going on with your data or with your business, and it helps you to, of course, make informed decisions. So when you know that for the things though where the cost is between 4 and 375 or even higher than 375, people are not buying. Order quantity is not a lot. You know that you don't need to stock a lot of the products that fall within that category. But with the ones where the order quantity is likely to be high on the average, you know that you need to stock those products more. And you can really juggle this around. Just continue checking like all of the numerical values to see where there are correlations and what insights you can find that you can use to influence your decision making for your business. So that is how key influencers are used in data analysis and decision making. And the last interesting chart that I want to show us for analysis is the decomposition tree. Questions on key influencers before I go to the composition tree. Are we even paying attention? This one, nobody is asking question.
Yes, I'm paying attention.
Okay. So I take it that you people understand. That's why nobody is asking question. So I wanted to go to the composition tree. The composition tree, as the name implies, breaks down something from big to small, then to small, then to small again, then to small again, until when you get to the smallest unit, which is an atom. In science, did they say atom was the smallest unit or something? Or is it cell? I don't remember again. But yes, the composition tree breaks down something from the biggest unit into the smallest. And you can really use For decomposition tree, this is it here in your, you can see as the name implies, it starts from big and then goes into small branches. The first thing you need to add to your decomposition tree is a numerical value. So you can either use profit, total cost, total sales. We've been using profit since, so let's use total sales. So I drag total sales into analyze. And the moment you drag it, it just gives you the total, your total sales first, the entire total sales in the universe of your this thing. And we can try it just to be sure that it's correct. Can put this into a card first. So 1.12 trillion, which is what we have here. Let me expand it so that we'll be sure. Rollout value. Aha, 1.116956. So that's the whole entire total sales in the universe of our data. So now, how do you want to break it down? Or how do you want to, again, explain it? You can choose any of the data points in your this thing to break it down. For example, I can say I want to break it down by year. It's not showing anything yet. The only thing that just happens is that you see a plus sign in front. So you have to click that plus sign to choose how you want to split your data. So when you click this plus sign, it gives you all the options: high value, low value, or just here. And I'll show us what happens when we click each of the. If you click high value, shows you all the years. So now it breaks down this 1.2 million into all the different years, and it highlights the high value. If you again go back, you close here. If you say low value, again it breaks everything down and highlights the lowest value. But if you didn't click any of high or low, if you just say yeah, it just breaks it down and it shows you all the years. It breaks down the 1.2 million into all the different years. But this is like, this is not interesting, it's boring. The composition trees are most useful when you have hierarchies. So for example, after this year now, you want to break down the year into quarter, break down the quarter into months. And you don't have to necessarily have it created as an hierarchy, even though it's better if you have it that way. But even if you don't, as far as you know that those things make up an hierarchy, and I'll show you another example, you can then put quarter under year. So again, as usual, it's give you the option of high, low, or just quarter. So now you see all the quarters that make up these years. And then you can then have month name under the quarter. So now I can break down this quarter 2 into the months in quarter 2, April, May, June. So this just continues to break it down until the lowest, the smallest unit of life that you have in your data. So I can even still break down April into all the dates in April. I'm sure that's going to be a ton. Yeah, so you can just like really keep breaking down your data as long as you have those hierarchies. And another place we have a hierarchy that we can break down is, I think, categories. I think we have product categories somewhere. Yep. So we have first, we have the category. So I'll have to remove the dates from here. Then by product category, then product subcategory, then product's name. As you're adding it, until you come and click this plus, it will not show. So let me do this and say low value. Oh, okay, product name. No, you have to start from the largest to the smallest. Product category. Then the beauty of the composition tree is that you can choose any of the categories to split. So I can say, come here and then say, can either choose cell phones or audio or anyone, and say, yeah, go to product subcategory. Okay, so there's only one subcategory here. Or I think the subcategory is supposed to be before the category. Oh, okay. Then these are the subcategories here. Then under digital cameras, you can then go to all of the product names. Now, I usually like to explain the similarities and the differences between using this and using a regular column chart. And I would duplicate this and change this to a column chart. What's going on? I am trying to have profits by product category. Good. Main categories here have computers, cameras, cell phones, cameras and camcorders. Okay, so you know that even with this even with this column chart, you can still drill down. If you carry your product subcategory and put it here, and then carry your product name and put it here, and then activate this drill down, or drill mode is on. You can go from, you can click computers, and then it takes you to all the things under computers. And then you can click again, printers and scanners, takes you to all the products under printers and scanners. Or you can also use this, go to the next level. This one takes you entirely to product category. Go to the next level again. Sorry, subcategory, go to the next level again. It takes you to product name. Depending on, so this also has drill up and drill down capabilities. However, the reason why I think the decomposition tree is better is because when you're drilling down in the composition tree, it doesn't take out the first level. You'll be seeing all of the levels at the same time. Whereas in column charts plus decomposition. Whereas in column charts, you can only see one level at a time. I don't know if I'm making sense. Like here, even if you use any of these options, you can only see one level at a time. Or even if you use this option, even if you use this option, unlike then, now when we drew down from cell phones, you can still see all of the parents, cell phone to cameras to, but here you can just see one level at a time. Another advantage that the composition tree has, for example, is that you can actually jump levels. So from here, I can actually jump straight to product subcategory without going first through product category. I can even jump and go to product name, depending on whatever it is that I'm trying to achieve. And I mean, he also has the automatic thing of showing me the high value in the category, in whichever category I'm choosing, without having to do top N or whatever. So that's just one advantage that, like, I think that the composition tree are very similar to column charts with a drill down, but with a decomposition tree, you can see all of the levels at once, and it just makes your analysis a lot more interesting. So as many items that you have under the hierarchy, you can really continue adding them, and it will continue to drill it down. As long as you have space, your laptop screen is wide enough, it will continue adding them for you, and the tree will continue to branch out and branch out and branch out and branch out. And you can see these blue lines that show you which of the parents it goes to. If you change to this one, the line moves. If you change to this, you can highlight any of this thing, and the blue line will always highlight which one is speaking to and things like that. So that is that for the composition tree. So all of these are just different ways that you can add insights to your charts instead of just building charts for the sake of building charts. All of these things help you to add insights to your charts, just so that the charts make more sense to the people that are using it, and they can see what you're trying to pass across with your charts. I think that's all what we are going to cover on analysis. In the next class, we're going to go on to Power BI service. So if you have any questions, either on something that we did today or something that we have done in all of the different classes that we had, please feel free to ask. I'm going to upload this because I feel like this this Power BI file manages to cover most of the things that we did in Analyze Data. So I'm going to upload this particular Power BI file on the channel so that anybody can download it and use it for their personal learning. Are there any questions, either from what we've done today or what we have done in previous classes? If you guys don't have questions, better for me. Good evening, Lara.
Good evening. Yes, thank you. Thank you for your class today. Is there any situation where on the decomposition tree I can show two levels at the same time? Let's say like 2011 and 2014. I know the data may look a bit muddled up because I'm saying like 1, 2, 3, 4, 5, 6 categories, but I'm just asking, is there any situation
What do you
where
mean by two levels?
So for the year, for example,
Oh,
can I show 2 years at the
Wait.
same time on the decomposition tree?
Okay, wait, let me see. I think I understand what you're saying. Let me duplicate this page. Remove all these things and put here. So instead of breaking down only 2021, you want to, 2012, you want to break down 2012 and then break down 2014.
Yes.
Right?
Yes.
No, it's not possible. You can only show one at a time.
Okay.
The only additional thing that is possible in the composition tree, you cannot show, like I said, you can't show two of the same data points. You can only show one. The only thing is you can show another thing entirely. Like here, we're showing total sales. You can show profit as a tooltip, which is something that is possible in most other Power BI visuals anyway. So if we show profit as a tooltip, what a tooltip means is that when you hover over this guy, you see both the total sales and the profit. That's the only other thing that is possible that I didn't mention. But you cannot expand two data points at the same time. You can only choose one. The moment you click the second one, the first one will go.
Okay,
or maybe you can read up on it, and if you find something, you can come and teach us next week. But as far as I know, you can only show one at a time.
Okay, very well. Thank you.
Yep. Any other questions? Let me add tooltip here. Any other questions? People are not asking questions. Anyway, there was something else I wanted to say when I was talking about grouping and binning. I remember that I said that you can bin numerical values. However, you can only bin values that have a column in your data set. So for example, if you look at this unit cost, unit price, order quantity, they are columns, but profits, total cost, and total sales are measures. So for measures cannot be binned, and I will explain why. You know, like I said, when you are binning, when you want to bin, for example, this order quantity, the reason why Power BI is able to bin it for you is because Power BI can see a minimum value and a maximum value. And that's because there's a column somewhere that has all of the numbers that represents order quantity. However, you remember that when we were teaching about measures, when we said that when you create a measure is like something hiding in a corner waiting to manifest. The moment you create that measure, there are no values anywhere assigned to it until when you call it. When you call profit, at the point when you call profit, that is when this thing calculates. There's no data stored anywhere as profit. The only thing that is stored is a measure. And what I mean by there's no data stored anywhere is that before I called this thing, there was no, you can't come to this, like these are our data view. You can't come here and see profit here. So it just looks like when you want to do that bin, Power BI comes here and tries to look for the numbers that we are binning. But because those are measures, there are no numbers here that represent them. So Power BI will not even know what to bin because there are no numbers anywhere that represent profit. Profit is a measure, and it only becomes a number when you call it in a visual. So you cannot possibly bin it because Power BI doesn't even know what your minimum and your maximum is for a measure. Because when you call profit here, the minimum and maximum is different from when you call it. Maybe when you call it in another visual and put a filter, the minimum and maximum is different. So measures cannot be binned. Only columns can be binned because, like I said, when Power BI comes there and looks for your measure to find the things that measure to find the numbers that make it up, minimum and maximum, it doesn't see anything. So it doesn't know what to bin. So you can only bin, like I said, numerical values, and they have to be columns and not measures. You cannot bin measures. I don't know if I'm making sense, but I'm speaking gibberish. So I mean, that's just one of the things that determines how you do your analysis from the beginning. How do you decide, should I use a measure? I think someone asked that question the day we're talking about measures and columns, when to use a measure and when to use a column. Measures are usually more advisable because they don't occupy space in your model and they help your model to perform faster. However, it's a trade-off. If you know that in the future, you are going to need to bin that data point, then you don't have a choice than to use a column. Because if you use a measure, you will not be able to bin it. I hope I'm making sense.
Yes, you are, but can I undo it if, for example, the project I was given initially didn't require me to bin, and then I had used measures, and then maybe another supervisor now came and said, "No, I require to group it using
Yeah, of
binning,"
course. You just
something.
have to now create a column and then replace it. The places you have used, the places they had used the measure, you then use the column. For example, I can come here and create a column and call it profit.
Okay, like say profit 2, right?
Yeah, or say like call it any other name and then use it for your binning. But why do you want to clog up your data model with two different data points doing the same thing? In the end, you just want to keep one of them and then delete the other one. Are there any more questions? Why don't I have assignments today? Let me look for assignment. The one I gave last week, nobody did it. So why should I be encouraged to give another assignment?
Sorry, please give another one. Do everything.
Okay. Today's assignment is something that we should have done last week, but we didn't do it. So I'll just give it an assignment. You know that
Sorry, Yinka. Hello, Yinka.
Yes, I can hear you.
Okay, I was also going to suggest that they do the last assignment too, since they haven't done it.
Done it. Then let me give
Yes.
them. I will give them additional one.
Okay, so they have 2 assignments.
Yeah, so they have 2.
All right then.
So when you create a chart and you come to this I'm not saying what I'm looking for. When you create a okay, when you create a line chart.
Sorry, Chigozie has her hands
up.
up. Is she? Yes. Is that
okay, Chigozie?
Okay.
Let's have your question.
Yeah. I have a question. I'm trying to understand. Is measures the same thing as SQL?
As what?
SQL. Is it the same?
SQL.
Or different? Yes.
By SQL, you mean SQL?
Yes.
How will I explain it now? No, measure is not SQL. But a measure is something that you create with a formula in Power BI. So for example, when I come here, there are 2 things. I can either create profit and add it at a column, or instead of adding it as a column, I can just write the formula and keep it. That is when it is called a measure. And when I write the formula and keep it, so for example, I created the formula for profit and we called it profits is equal to total sales minus total cost. It's a formula, it's not a number yet. It's just a measure or a formula that is kept somewhere. It becomes a number when you call it in a visualization.
But that's measures.
Yeah, it uses the DAX language. I don't want you to confuse it with SQL. SQL is like another language entirely. But measures use the DAX language, which is what Power BI uses.
Okay. Thank you.
Yep. So yes, so I was trying to give you assignments. In Power BI, because Power BI has smart insights, when you create I'm already answering the question. I will just write it before I talk plenty. Assignments 2. I will put the 1 in front of the 2 so that people will not say you forgot. Preferably, somebody will do demo for us of all of these assignments. These assignments 1. Assignment 1 is the application of conditional formatting with web URL. Assignment 2 is forecasting in line charts or with line charts, whatever.
Sorry, the first assignment, what are we to find out? Is it the relationship or the...
No, like how to use it, how to use conditional formatting, how and when.
Okay, please can you put it there? So
for both of them, actually, how and when to use it. For both of them. It's the same thing for both of them, forecasting in line charts. How do you use it and when do you use it? Because it is one thing to know how to use it. It is another thing to know when to use it. That's why when they give you work in the office, even though you know forecasting or you know conditional, you not remember that it's conditional formatting that you're supposed to use to do the work. So how to use it and when to use it. So that brings us to the end of today's class. If there are any more questions. Thank you for coming. I will try to get with the Funmilayo.
Okay, so for the assignment now, is it just for us to read it and explain to you next week, or do we have to do like a practical or something while explaining it? Or
If
could
you
just
want
read
to
up?
do a practical, is nice. But you can use math and explain it. But if you do a practical, I will know that you understand it very well.
Okay, thank you.
Yep. Any other questions? Okay, guys, it was nice having you. Enjoy the rest of your weekend. Any final thoughts from Franca?
No, that's okay. So we'll see you next Saturday.
Yes, please.
Okay.
Please, let's not come late
Have a
like
nice
we came
weekend.
late today.
Exactly. Yeah.
Yeah. Thank you.
Madam
All
Ika,
right. Good
Saturday, no
night.
inspiration.
Sorry? Somebody's saying something.
Saturday, no inspirational session.
No,
Oh,
next week is
inspirational
not
session.
inspiration session yet. It's the last Saturday, which is
Okay.
24th.
Yeah.